Welcome to the fundamentals and computations of concentrations. In this part, we're going to look at weighing powders. So there are a number of different lab tools that you need for weighing powders. One of the most important is the balance. Okay, it's also referred to as a scale, but in short, scales or balances can cost different amounts. They can have different precision. Sometimes in labs, a balance will have 2 decimal places. Some will have 3 decimal places, and some will have 4 decimal places. Okay, a 2 decimal place scale is pretty basic, but it's precise enough for many lab measurements. 3 decimal scale is quite precise, good for the majority of lab measurements, and a 4 decimal analytical balance is what it's called, is the most precise, and it's suitable for all measurements. However, often analytical balances will only allow measuring up to 200-300 grams. So if you're ever in a lab and you need to measure a kilogram of something, often a 2 decimal scale is sufficient to do that. Okay. Other tools include scupulas. These are spoon-like devices that help you to scoop the powder from your containers and put it into your your containers that you use for weighing. You also have a spatula. It's like a scupula, except it's more like a spoon, and they're also used for scooping powders and putting them onto your weighing containers. Now, 2 weighing containers are tools that are useful within labs and used very widely. One is the weigh paper, and this is a thin, waxy paper. Generally, you fold it in half before you put it onto your balance. And then you add your powder onto it bit by bit until you reach your desired mass. Okay. There's also weigh boats. These come in many different shapes and sizes, and the same principle applies. However, you don't fold them. You typically will just put them on your balance. You'll add your powder to your desired mass, and then you can take them out. And they're quite handy because you can squish them, and the end or a corner can be used as a little spout to pour your powder more accurately into your container. Okay, so balances, weigh papers and boats, and scupulas and spatulas are the 3 main tools used for measuring and weighing powders. So a little bit more on balances, because this is one of the most important tools, I guess you could say. I mentioned a little bit about precision, but this is, I guess, really important, and it's more to just emphasize that different scales will have different precision, meaning it'll have a different number of decimal points. Okay, and to kind of focus in a little bit more on this bottom one here, this is called an analytical balance. Generally, they have 4 decimal places after the decimal here, and because they're so precise, they have a little cabinet around them to stop air from hitting the balance here. Okay, because air can easily move the values that you're measuring up, even into the milligram range up here, like the hundreds of milligrams. Okay, so but especially at the this is the micrograms here. So yeah, it's really important to know, and if you're in a lab and you see something that looks like this, know that it's an analytical balance and it's meant for precision measurements. So I just mentioned on the right a couple moments ago, but here's a quick question. If an analytical balance or scale can measure 0.0001 grams, what is the measurement called when you use a unit prefix? Right, so we've got gram, 100 milligrams, 10 milligrams, 1 milligram, 100 micrograms. Okay, so that's a very, very small mass. Often when you're loading these, you would open the door, put in your weigh boat or your paper. You can add the powder before or during, depending on how accurate you are. You just need to make sure you clean up after yourself, and then you close the door. So yeah, it's important that when you're using an analytical scale that you close the doors while the measurement is taking place. Okay, so a little bit of lab etiquette here when measuring powders. So often in science labs, there are communal scupulas or other spatulas, etc., that are used to collect powders and do measurements. Okay, so they're communal, and so it's important that you clean up after yourself. All right, you don't want to use all of the scupulas, and so when somebody's starting their experiment, they have to go clean them. That's just not good lab etiquette. You can clean scupulas using clean water or different solvents based on what you're scooping. But you want to make sure that the water or the solvent is pretty pure so that you're not contaminating the scupula, right? So because it's reusable, you need to make sure you don't contaminate it for your next measurement or the next measurement of your colleagues. All right. A third point about lab etiquette here is it's good practice not to put back remaining powder on the scupula, or if you accidentally overmeasure and you need to remove some, it's good practice not to put that back in the main container, because perhaps there's a little contamination in your weigh boat. Maybe your scupula was slightly contaminated, and if you put that back into the main container, you're going to contaminate the entire batch. Right? So generally speaking, you should put any extra powder in the disposal. Okay? So you want to do a good job of not over scooping and not adding too much extra or getting too much extra onto your scupula. All right, so a little bit more lab etiquette here. It's very easy to get powders over the counter and the balance when you're measuring and moving the powders around. So it's really important that you clean up after yourself immediately if possible, or if you need to rush into an experiment, then right after you're available. You don't want to get a bad reputation in the lab, and you don't want to create tension in a lab, right? It's important to clean up after yourself, or if you're in a lab that has support staff that can help, it's important to be aware of how it is going to be cleaned up. Okay, but in general, you should clean up after yourself. Okay, so here's the last part: how to use a balance. So step 1 generally involves putting on lab PPE like gloves. You don't want to contaminate the containers, the spatulas, the powder, the balance with the oils and the microbes on your hands, okay? And you also don't want to, contaminate your skin or get exposed to chemicals. So in general, you should wear lab gloves, pretty important. You get your tools ready, so you make sure you got a clean spatula or scupula, the balance is clean, you've got weigh boats or papers available. You get your powder. If your powder just came out of the fridge or freezer, it's important to allow it to warm to room temperature before opening the container, okay? I can't stress this enough. I'm going to leave it mysterious here. If you don't know why, there's going to be an activity where you can troubleshoot that and think it through. But if your powder came out of the fridge or freezer, it's important to let it warm up first, okay? If your powder was at room temperature, just in a chemical cabinet or on a shelf, go ahead and use it right away. The next step here is to place a new weigh boat or a folded weigh paper on the balance and press the tare button. The tare will zero the balance, so it should read 0.000. If you're using an analytical balance, it might say 0.0000 and then maybe fluctuate to up a 1 or a 2 or a 3, just very, very, very small fluctuations. This might be due to vibrations through the counter or something like that. But in general, when you press tare, you should be able to wait, let it stand, and it should go pretty much to 0. Okay. Again, if you're using an analytical balance, make sure you close the door before you tare so that it all gets settled. There's no air movement that's impacting your tare, and that'll make your measurement more accurate. Okay, so after you press tare, you can add powder to your weighboat or paper bit by bit. And so your goal is to get to the correct mass of powder efficiently, so in as few scoops as possible, but you don't want to overfill it, and you don't want to take too much extra powder on your scoopula or spatula, because again, that should be discarded and not put back into the primary container because you could contaminate it, right? Another question might be, how exact should you be? If you're using an analytical balance, how close could you possibly get to 1 gram? It's quite difficult. And so the answer is it depends on your experiment, and it depends on you, and it depends on your time, right? Often if you can get within 1% of your target mass, that's pretty great. Let's say if you want 1 gram, if you get to 0.99 or 1.01, that's pretty good. 2 to 3% is okay. It's not great, but it's okay. So really it's kind of up to you and how accurate you want your measurements to be, right? This could be a fun question to ask colleagues in the lab is, how accurate do they try to get their measurements, and how much time do they spend, right? All right, and then the last step is, once you've reached close or exactly to your desired mass, you can carefully remove the weighboat or paper from the balance and pour it into your container. So when you're moving the filled container out, that's when you can accidentally drop some powder. So you just want to be slow and careful. You don't want to breathe on it. Breathing on it will create air movement, and that can cause some powder to float into the air. Okay, so you want to be careful because you took all this time to measure that mass accurately. You don't want to lose any of that while moving it to your final container. Thank you very much for following us in this series. We hope you learned a lot about unit prefixes, about concentrations, from the percent weight volume and the percent volume, through mass concentration, through molar concentration, and ultimately to dilution concentration. We learned a lot about concentrations. And then lastly here, we talked about using a balance and how to actually do measurement and the tools that are required. So hope that helped you understand the process better, and good luck in your scientific endeavors.